I'm Anil Kumar sharing with you a test question. Question number 2 here is how many tangent lines to the curve y equals to x over x plus 1 pass through the point 1, 2? At which points do these tangent lines touch the curve? Let us discuss the solution in details. So the question is, we need to find how many tangent lines will go through this curve and pass through the point 1, 2. Point 1, 2 is external to the curve, so more than one tangent can be drawn, right? At which points do these tangent lines touch the curve? So we need to find the points on the curve where a tangent from the point, external point 1, 2 can be drawn. If I substitute 1 for x, I get y value is 1 over 1 plus 1, which is half, not 2. Therefore, this point is an external point, right? Now, let us assume that the point on the curve is, let me write down here, let's say point P on curve is a, the x value, then the y value will be a over a plus 1, correct? So that will be the point on the curve. And let us say the external point given to us is q, which is 1, 2, right? Now in that case, what is the slope of the tangent line? In general, we can write, we have y as equals to x over x plus 1. Y dash at x equals to a will give a slope at any point a on this curve. So let's find the derivative, and then we'll substitute x equals to a. Denominator is x plus 1 whole square. We are applying the quotient rule. Derivative of numerator 1 times x plus 1, so we get x plus 1 minus derivative of x plus 1 is 1 times x, right? So that becomes the derivative. So at x equals to a, this derivative will be 1 over a plus 1 whole square, right? So that is the derivative at x equals to a for any tangent line at a, right? Let us also find the derivative of this function. Rather, I should say the tangent of the slope of the line. Let us also find tangent slope from point 1, 2 to the given point. So that will be mpq, which will be y2 minus y1 divided by x2 minus x1. So we can write down y2 as, let us say, a over a plus 1, a over a plus 1 minus 2, that is y2 minus y1 divided by x2 minus x1, a minus 1, right? So that becomes the slope from external point to the given point. Now both these slopes should be exactly same. So let me simplify this expression here. So we have a minus 2 times a plus 1 divided by a plus 1 times a minus 1, right? That could be, well, we'll move on to the right side and then simplify the expression. So what we have here is these two equations for the slope, and both of them should be exactly same, right? So we can equate these two equations. So we will say, well, these equations should be same, right? Both are slope between two given points, which are P and Q. So we'll equate them. So we say 1 over a plus 1 whole square should be equal to this expression, which is a minus 2a gives us minus a minus 1. So I'll simplify also while writing here. So minus a minus 1 divided by a plus 1, rather minus 2, 2 times 1 minus 2. So, okay, now here we have a plus 1 times a minus 1, correct? Now to solve for a, we can cross multiply and then simplify. So we'll just cross multiply, so we get a plus 1 times a minus 1 on this side equals to, here we can take minus of a plus 2 times a plus 1 whole square. Let's bring all the terms together on one side to solve for a. So we get a plus 1 times a minus 1 plus a plus 2 times a plus 1 whole square equals to 0. I'm not expanding, I'll take a plus 1 common. That is a better way to simplify this equation. Otherwise it can be very complicated, right? So a minus 1 and factor out. So here we get plus a plus 2 times a plus 1. We took one of those factors outside, right? So one value of a is when a is equals to minus 1. Now a cannot be minus 1 since that is a vertical asymptote here. So that's not a valid point. So let's look for this factor to be 0. Okay. So let's simplify this. We have a minus 1 plus multiply. So we get a square plus a plus 2a plus 2, right, equals to 0. That is a plus 1 times, this is a square. So a, 2a and 2a, 4a is plus 4a minus 1 plus 2 is plus 1 equals to 0. So we get this equation, a square plus 4a plus 1 equals to 0. We can find the value of a which can make this 0, right? So this gives us a equals to minus 1, but that is not valid, right? Not valid since x cannot be minus 1, correct? Now here we should write this restriction here, right? So we know that x is not equal to minus 1, right? Now we will solve for a from this equation. So we have a square plus 4a plus 1 equals to 0. We can use quadratic formula. So a equals to minus 4 plus minus b square, which is 16, minus 4ac, 4 times 1, which is 4, divided by 2 times a, right? So which is 2. So that is minus 4 plus minus square root of 12 divided by 2. Now this could be written as minus 4 plus minus. This is 4 times 3, so I can write 2 square root 3 over 2, and then let's simplify, minus 2 plus minus square root 3. So these are the 2 points for a, right? So therefore, at which points do these tangent lines touch the curve? The points are, so we find that there are 2 points, right? So one point is when a equals to minus 2 plus square root 3. The other one is minus 2 minus square root 3, right? So these are the 2 points. These are the 2 x values on the curve, right? So that is our answer for the given question. I hope that helps. Thank you and all the best.